Hello class, this is lesson 11.4, which talks about angle-angle similarity of triangles. So in this lesson we're going to be looking at some similarity theorems. One of them is going to be the angle-angle, which we'll talk about. We are also going to cover a side-angle-side similarity theorem and a side-side-side similarity theorem. I do want to mention though that going forward from these lessons, we're going to be focusing on triangles, so looking at similar triangles. As before, in the previous lessons, we looked at different types of polygons, rectangles, and different types, but this is going to focus on triangles. And these similarity theorems only apply to triangles. So let's start with the angle-angle triangle similarity theorem. If two angles of one triangle are congruent to two angles of another triangle, then the two triangles are similar. So let me kind of walk you guys through that. If you have two angles, let's say angle J and angle Q are congruent, and angle K and angle R are congruent, just by knowing two angles are congruent, you can say that these two triangles are similar. So triangle JKL, this symbol means similar to triangle QRS. So we're actually going to be skipping some of the proofs of how they derive that, and going straight into some problems. So let's skip to page 26. Okay, so once we identify that two triangles are similar, we can use some of the properties that we learned last lesson to find missing sides or missing angles or missing variables. In example 1, we have this figure here, and they want us to find BE. So they want us to find this length, which I will just call X for now. Now, one thing that they actually tell us is, let me kind of zoom in on the figure, is that AC and ED are parallel lines. Now, going back to Geometry A, the start of Geometry A, we talked about parallel lines and the types of angles that are formed from parallel lines. One of those were alternate interior angles. So if you imagine I extend this parallel line out, extend this one out, and extend this one out, this angle here and this angle here are alternate interior angles, and this angle C and angle E are also alternate interior angles. Now, alternate interior angles are congruent to each other. So just by knowing that these two lines are parallel, we have two angles equal to each other in both triangles, and we could use the angle-angle triangle similarity to prove that these two are similar. So now that we know they're similar, we could actually solve this problem by creating a proportion, because remember, when we're solving for sides of similar figures, we create proportions. So the proportion that we're going to be creating, we want to say BD, so this side, over BA is equal to BE over BC. And if we look at the proportion they created, we substitute 54 over 36 equals BE over 54. So what I'm going to do is I'm just going to use X for BE. So 54 over 36 equals X over 54. Then they cross multiply, 36 times X, and then 54 times 54. And then they divided both sides by 36, and they get X is equal to 81. So what we did was we first stated that these two triangles were similar by using the angle-angle triangle similarity theorem. Then we were able to use the properties of similar figures to solve for x. And we're going to be doing the same thing for the next problem. So let's look at this next problem here. How can we use the angle-angle triangle similarity theorem? If we look at this figure, we have one angle. So they tell us angle S and angle T are congruent, but we need another angle. We don't know these lines are parallel, so we can't say anything about angle V or U. But one thing that we know is that this small triangle and this larger triangle share this angle R. So actually, angle R is congruent to angle R in both triangles, and that's our two triangles, or I'm sorry, our two angles that we need to use the angle-angle triangle similarity theorem. So next, now that we know that, we could create our proportion to solve for RT. So in this problem, they want us to solve for RT. Now what's going to actually help is if I actually separate these. So let me kind of separate these two. So this is the small one. This is the big one. So you have R, V, S. We know this is 10 and this is 8. And then we have R, T, U. So we know this is 12. And what we want to find out is RT. So I'm going to call So actually, RT, if we look at RT here, we know RS is 10. We don't know what ST is, so I'm going to call that one X. And the reason why I want to do that is because to find RT, I need to call this 10 plus X. So it's 10 plus whatever this number is, 10 plus X. Then you could kind of choose however you want to create your proportion. So what they did was they said RT over RS. So I'll kind of just show you here. 10 plus X over 10 equals TU over SV, 12 over 8. They cross multiply, so 10 times 12, 8 times 10 plus X. They distribute here. So we get 80 plus 8X equals 120. And they divided both sides by 8, and they got X equals 5. Now that does not answer our question because the question was what is the measure of RT? And if we look at RT, it is 10 plus X. So 10 plus 5 becomes 15. So the problems that you're going to be working on are going to be really similar to these. Using the angle-angle triangle similarity theorem first. Okay, so let's look at these two examples. So the first question you need to ask yourself is how can you use the angle-angle similarity theorem for this problem? If we look at figure, or problem number 1 in this figure, we have triangle ADE and triangle ABC. Now we know that we have parallel lines right here, and that's a good hint that we're going to have some congruent figure or congruent angles. Parallel lines have corresponding angles. So let me kind of do a drawing on the side. So imagine you have two parallel lines and a transversal that cuts the two parallel lines. What forms are corresponding angles? and corresponding angles are congruent. So we could say angle E and angle C are congruent. And then they both share angle A, so that's another one. So all we need are two angles to use the angle-angle similarity theorem. Knowing that these two are similar, we could solve for AB. So what I could do is let me just draw the small triangle, and then we draw the big triangle. So the small triangle is A, E, D, and then A, B, C. And labeling everything, I have 9, 6, this is 15. And now AB is actually going to be 6 plus X, because this DB is X. So this is going to be 6 plus X. Then creating your proportion. So you can do your proportion any way you want. So I'm going to say AB over AD is equal to BC over DE. And then substituting, I get 6 plus X over 6 is equal to 15 over 9. Cross multiplying, you get 15 times 6 is equal to 9 times 6 plus X. 15 times 6 is 90. So you get 90 is equal to 54 plus 9x. Subtract 54 to both sides, and you get 36 equals 9x. Divide both sides by 9, and you get x is equal to 4. But again, that does not answer our question, because our question is, what is AB? So AB is equal to 6 plus 4, which is 10. So again, we use the angle-angle similarity theorem first, and then we're able to use the properties of similar figures. Okay, and then question number 2. The question is asking, what is PQ? So let me just put a X right there. And if we look at these two figures, they actually tell us that angle P and angle T are congruent. This angle and this angle are congruent. And they actually tell us that angle S is 90 degrees, but that means that this is also 90 degrees as well. So we have another pair of congruent angles here. So we could use the angle-angle similarity theorem. Now that we're using the similarity theorem, we have to create our proportion. So before we do that though, let me kind of just walk you through, let me kind of just draw the two figures, how they would look if I was to put them in the same direction. So I'm not going to change the small one. The small one's going to stay the same. That's going to be TSQ. This is 9 and this is 15. And I'm going to rotate this top one. So this is P, this is S, and this is R. And SR is 12. And PS, we're going to call that 9 plus X. Because that's 9 plus X right there. And this is a right angle as well. Now that we have this facing the same direction, we could see which sides are proportional to each other. So we could see that PS and TS are corresponding. So we could say PS over TS is equal to RS over QS. And then substituting the values, I have, let me do it over here, 9 plus x over 15 is equal to 12 over 9. Then I'm going to cross multiply. So I'm going to have 15 times 12 is equal to 9 times 9 plus x. Let's find out what 15 times 12 is. That is 180. So we have 180 is equal to 81. So you're distributing plus 9x. Subtract 81 to both sides, and you get 99 equals 9x. Divide both sides by 9, and you get x equals 11. So then to find PQ, PQ is equal to 11. Okay, next we're going to be doing something similar, but now we're going to be looking at some other triangle similarity theorems. The first one is side, 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 and the second one is going to be side, angle, side. But let's start with the side, side, side triangle similarity theorem. And it goes like this. If the three sides of one triangle are proportional to the corresponding sides of another triangle, then the triangles are similar. So another way to determine if two triangles are similar is by looking at the proportional sides. If all three sides are proportional, then we could say the two triangles are similar. The next theorem is side, angle, side triangle similarity theorem. And if you look at the name of the theorem, it kind of tells you what we need. We need two sides and an angle in between. So if two sides of one triangle are proportional to the corresponding sides of another triangle, and their included angles are congruent, then the triangles are similar. So let's pick two sides. If we know AB over XY and BC over YZ are proportional, and if we know the included side, so the included angle, the angle in between the two sides is congruent, so if angle B is congruent to angle Y, then you could use this theorem to prove that triangle ABC is similar to triangle XYZ. Okay, so now in the first example, we're going to determine whether the given triangles are similar. So we're going to be given two triangles. Triangle HJG and triangle LMN. Looking at the sides, we got to see what sides correspond to what side. So GH corresponds to LM, HJ corresponds to MN, and GJ corresponds to NL. So if you create that proportion with all sides, we could see if we have a if all sides are proportional. So plugging in the values, 8 over 12, 10 over 15, and 4 over 6, if you reduce each of these fractions, you end up with 2/3, 2/3, 2/3. Now what this tells you is that each side is proportional. So now you know that the two triangles, they are similar because of the side, side, side triangle similarity theorem. So you're just checking to see if the sides are proportional. Now let's pretend one of these was, let's say, 2/5. So if you see that you have 2/3, 2/3, but the last one becomes 2/5, then you cannot use the side triangle similarity theorem. So they have to all be the same. Okay, and let's do one example. Okay, so let's read the problem. Your friend incorrectly claims that triangle ABC is similar to triangle FGH by side angle side similarity triangle theorem. Explain or show your friend their misunderstanding of side angle side similarity theorem. So if we look at this figure, we have some sides and then we have some angles. Now let's kind of write what we know. We know that angle A is congruent to angle F because they tell us here angle F and A are congruent. Now let's look at the sides. Let's check to see if there are any proportional sides. HG and CB correspond. So you could say HG over CB is equal to HF over AC or CA. Then substituting the values, we get 3/6 equals 5/10. Reducing both, I get 1/2 equals 1/2. So we have two proportional sides, and then we have an angle that's congruent. But the issue in this problem is that we're not using side angle side, because to use side angle side, the angle has to be in the middle of the two sides. If we look at this figure, we have side angle, side angle. What we needed was this angle. If we knew angle C and angle H were congruent, then we could use side angle side. So to answer this question, we cannot use side angle side in this problem because we needed to know that angle C and angle H were congruent. Okay, and that pretty much wraps up this lesson. Let's look at the homework. So in the first questions, they're just asking you if the two triangles are similar due to the angle-angle similarity. So you're just looking to see if you have two angles congruent to each other in each triangle. And then let's look at problem number 4. Let's do that one together. What should angle F and angle Z be to make these two triangles similar? So for these two to be similar, angle F needs to be the same as angle Y. So angle F needs to equal 77 degrees. And angle Z, if we look at angle Z, which one goes with angle C? That is angle H. So angle Z needs to be 55 degrees. And that would answer your question. All right, guys. Well, have a good day. Please work on this. Try to do it through Cami. If you have any questions, please respond or comment on the homework. Thank you.